AP Statistics. In this video, we are still in Unit 1, and we are talking about outliers. What is an outlier? Well, an outlier is an unusual feature because it looks like it is separated a great distance from the majority of the rest of the data. So we want to know how to determine if, in fact, a value is truly an outlier or if it just looks like an outlier. Let me demonstrate what I'm talking about. I have a set of data here in Staplet, and I've just called this test scores. So if you'll notice from the dot plot, I've got a lot of values up here above 60, but then I've got these three values that are a little bit lower. So I've got a low value at what appears to be 50 something, 57, and then I've got a value at 43, and then way down here I've got a 32. So it looks like the 32 might be an outlier. It actually looks like the 43 might be an outlier as well. But you'll notice I really can't just guess at that. I can look at it and say it looks like it might be an outlier, but if I want to know for sure, I've got to run the outlier test. And what do I need to run the outlier test? Well, if you'll notice over here in our notes, we need to know Q1 and Q3, because if we know those, we can find the IQR. So let's go back to our data and notice this little table down here of our summary statistics, and we do have Q1, it's 67.5, and we have Q3, it's 87.5. So I'm going to go back to my notes and I'm going to calculate the outlier test. Notice I am calling it the outlier test. I'm not calling it the outliers. Okay, the outlier test is to see if the values in the data we suspect to be outliers are in fact outliers. So running the test is to ensure whether or not those low values are outliers. So when I run the test, I want you to see what happens. I'm going to take Q1, which I already said is 67.5, and I'm going to subtract 1.5 times IQR. Well, the IQR, remember, is Q3 minus Q1. So in our case, Q3 is 87.5 and Q1 is 67.5. So that is what I'm going to do. So I've got 67.5 minus 1.5 times 20. If you're doing this in your calculator, please be careful and follow PEMDAS, because you have to multiply this before you subtract. Okay, just throwing that out there. So what I get when I do this calculation, 1.5 times 20 is 30. So 67.5 minus 30 is going to give me 37.5. And then I'm going to find the upper bound outlier test value. So that's going to be 87.5 plus 1.5 times 20, which is going to give me 117.5. Okay, so the values we have found here are 37.5 and 117.5. These are not outliers. They are boundaries. What do boundaries tell me? They tell me that any piece of data that falls below 37.5 is an outlier, and any value above 117.5 that's found in my data is an upper outlier. So going back to our data, I want you to notice that this value, this low value right here, see the minimum, you can see it in the summary statistics, is 32. So 32 is lower than 37.5. So the set of data I showed you does in fact have a low outlier. 32 is below 37.5, so that piece of data qualifies as an outlier.